Here is an application of multiplication of vectors. Vector u and v are given to us. Draw vector v minus 2u. So we have two lines here. I'll make them vectors. So once we give direction, this is the magnitude, it becomes a vector. And let me give a name to it. The name is v. So this is my vector v with a bar on the top. And let's say this is my vector u. Right? So these are the two vectors given to us, and what we need to do is to draw a vector v minus 2u. So we have this v and we have my 2u. Let's draw minus 2u first. So minus 2u means what? U is going in this direction. So minus 2u will be twice the length in opposite direction. Do you understand? So that means instead of going left 2 units and 1 unit up, we can go right. So from here, let's go right. 1, 2, and 1 unit down. That gives minus u. Then again, let's go 2 units and then 1. So that gives you minus 2u. So if I draw this vector like here, so that vector represents minus 2u. Do you see that? So u was 2 units left, 1 up. So when I say 2 units left, 1 up, I get minus 1u. Another 2 units left, 1 up, I get minus 2u. Correct? So that's how we get. Another way to do it is, let's write down what vector u is. Vector u is minus 2, 1 up. So minus 2u is going to be, we'll multiply that by minus 2. So minus 2, 1 up times minus 2, right? So that gives us 4 minus 2, right? So from any point, we can go 4 minus 2. 1, 2, 3, 4 and minus 2. That gives you minus 2u, correct? So that is how you can get your vector minus 2u. Now vector v is already given to us, and vector v is 4 and 1. So that is my vector v, right? So if you have to draw vector v and minus 2u, then after at the head of this vector v, I can place the tail of 2, right? Minus 2u, and then draw it. And I get my vector v minus 2u, right? Now, since in this graph paper, I'm running out of space on the right side, what I will do now here is that I will translate v right there so that I can put the head of v right there, right? So let me do that. So if I put my head here, that means this arrow I'm trying to put here, right? Now, where should the tail be? So I have to come down 4 units and 1 down. So left 4 units, 1, 2, 3, 4 and 1 down. So that becomes still on the edge, but still we managed to draw it. So here we are with vector v. So that becomes vector v for us. Beauty in vectors is that you can translate them and they don't change, they remain the same. So that is v, and this is minus 2u, and once we join, we get the resultant, correct? So that is the resultant, and we'll draw this resultant in a different ink. So we have this vector here that shows our v minus 2u, right? So that is how you can draw the vectors on the grid. Now algebraically you can calculate how v minus 2u. That means v is 4, 1. So you get 4, 1 minus 2 times u is minus 2, 1. So what do we get? We get 4 and minus becomes plus, right? So plus 4, and as far as y is concerned, we get 1, and minus 2 times 1 is minus 2, right? So we get 4 plus 4 as 8 and 1 minus 2 as minus 1. Let's check. Did we get the same result? So starting from here, that's our starting initial point. That's the tail of our vector v minus 2u. 1, 2, 3, 4, 5, 6, 7, 8 minus 1. Perfect. So we can check algebraically whether our geometric drawing is perfect or not. It is, right? So these are different ways we can add and we can draw the vectors on the grid. So I hope you appreciate the scale factor. So we scaled it, that means we multiplied by minus 2, right? So minus gave the opposite direction. So we changed the direction with the help of scaling, and we changed the magnitude. Magnitude became 2 times for u. So both magnitude and direction were changed, and then we added minus 2u to v, and we got a vector v minus 2u. We checked our answer algebraically also. We found it perfect. I hope you appreciate it. Thanks and all the best.